Here's your review for prime factorization. So what is prime factorization? It's just a unique string of prime numbers that when you multiply them together, you get a target number. So in the first example, our target number is 24, and that equals 2 times 2 times 2 times 3. And all of those numbers in there are prime because they have exactly two factors, 1 and the number itself. The second example of 35, the prime factorization is 5 times 7, because 5 times 7 is 35, and because both of those numbers are prime. Okay, that was our second example there. So how do we find the prime factorization of a number? There are two main ways that we can do this. The first is our factor trees. Okay, and we would start with a number like the number 27. The first thing we need to ask is that number prime? Well, I know 27 is not prime because 3 goes into it. So we start by branching that number. 27 is equal to 3 times 9. Okay, and then because 3 is prime, what we're going to do is we're just going to bring that down to the next level. And we have to branch 9 here because 9 is not prime. 9 is equal to 3 times 3. And then when I check all three of those numbers, they are prime. And because they are, I know I can stop. So 27 is equal to 3 times 3 times 3. We'll try some more examples here. So we'll start with this 39 up here. 39 is not prime, so I need to branch it. 39 is 3 times 13, okay? And I know 3 is prime and 13 is prime, so I'm done. That was an easy one. So 39, the prime factorization equals 3 times 13. When I go to this number 11, 11 is already prime, so its prime factorization is just 11. Now for 120, I'm going to start with a fact I know, and we'll do 12 times 10. Okay, and then neither of those is prime, so I'm going to branch both of them. And I get 12 is the same as 2 times 6, and 10 is 5 times 2. I have 3 prime numbers there, but this 6 is not. So I need to keep going. I'm going to bring those prime numbers down. 6, I'm going to make 3 times 2. And then I have my 5 and my 2 from the 10. All of these numbers are prime, so I'm done. That's my prime factorization. I can write this using exponents, and if I want to do that, if you remember exponents, this would be 2 to the third power because I have 1, 2, 3 2's here. 2 to the third times 3 times 5. Alright, so at this point I want you to try a few yourself using that factor tree method. If you need to go back, you can rewind and watch what I did again. And you can pause the video here and do your work. And then on the next page you'll be able to check your answers. So here I'd like you to compare what you got with what I found for each of the 3 problems that you did. You may want to pause the video at this point so that you can check your work. If you don't understand the stuff with exponents yet, you can just check these here that I've marked off in red and make sure you have those same strings.
What do you think, Ava?
What? At least a 2 hour delay. Tomorrow? No.
How you feeling? Much better?
Yeah. I spent the entire weekend just finishing my work.
Did she at least like send it home?
No, it's because I missed 2 days of school, so I make them off.
Did she at least send it home for you?
Yeah.
With Kyle? One of your friends?
I just had to get it off.
No, you did not.
Yeah. I missed it. In the letter, it says you're only allowed to do the activities during the festival.
Oh, what a bummer. get it done?
Yeah. I did it only one day. I just decided to get it over on
That's
Saturday.
smart. We are hoping.
I still have to do
You can get on, you can finish, we'll finish it up at home. Hey, Allison, try, we're gonna make a big push on it, okay? Mom's not in third grade, I've already done my.
She's already past college.
That's a reward. You earned that.
Should I go put the
I love how I was like, I've already passed third grade.
That's right.
I'm willing to help you out someday.
Take my dues. Exactly. Have you always just
Put this in perspective.
You playing solitaire? I'm like, yes I am. Yes I am. That's what I do.
follow.
I did do some freestyle during that time.
Yeah, exactly. It's brain training.
I don't think it's
No.
Are we parents?
No, we can't. No, it's class time.
So in summary, what you want to do is you have your number. In this case, our number here is 16 that we're starting with. And we choose a factor pair for that number. You can choose any one you want. I chose 2 times 8 as my first pair. Okay. In that, 2 was prime, but 8 is not. So if the numbers are prime, we're just going to carry them down, which I did. And then if they're not prime, you have to branch them. So I branched the 8 to 4 times 2. And then I'm going to repeat that sequence until all of the numbers are prime. So down here at the bottom, I ended up with 2 times 2 times 2 times 2, and they're all the same and they're all prime. The second way we can do this is by using what we call the birthday cake method, or the upside down birthday cake method, because really when you do it, you end up with a shape like an upside down birthday cake. We're going to start with the number 45. And in this method, you have to choose a prime number to start dividing by. So when I look at that number 45, I know that 5 is prime, and I know 5 goes into 45. So I drew this symbol here. It looks like an upside down division symbol underneath my 45. And I'm going to write my 5 over here. Then I'm just going to divide. 5 goes into 45 9 times. I write the quotient below this time. And then I'm going to check, is 9 prime? That's my question. Is that number prime? It is not, because 3 can go into that number. So I'm going to draw another little division sign. And I'm going to make the 3 go into my 9. 9 divided by 3 is 3. I write the quotient down below. And then my question is 3 prime? And in this case it is. So now I'm done. I have 5 times 3 times 3. And if we worked backwards, going up this way, we started with the 3. We could do 3 times 3 is 9. And then 9 times 5 is 45. So let's see how this works with 3 more examples. If I start with 18, okay, I know 2 goes into 18. 18 divided by 2 is 9. I write the quotient below. 9 is not prime. 3 goes into 9. 9 divided by 3 is 3. The quotient goes below. So I have 18 is equal to 2 times 3 times 3. For 26, I know 2 goes into that. I picked 2 because it's even and that makes it easier for me. 26 divided by 2 is 13. I write the quotient below and I know 13 is prime. So I'm done. 2 times 13. And for 12, again, I know that 2 works. 2 goes into 12 6 times. I write the quotient below. 6 divided by 2 is 3. All those numbers are now prime, so I can stop. Once I get a prime number down here at the bottom, I know I'm done. So 2 times 2 times 3 is the prime factorization for 12. So go ahead and give it a try using that method with these 3 numbers. If you need to go back, remember you can rewind the video and go back and look at that section again and see if you can remember what to do. and you can check your work on the next page. You might want to pause here while you do your work. All right, so here are the solutions for the problems that you just did. For the first one, we have 2 times 11 for 22. For 25, we have 5 times 5, or 5 squared, 5 to the second power. And then for 36, you can see what you should have here, or if you know how to write it with exponents, it would look like that. Just as a summary for the upside down birthday cake method, you're going to start with your number and make sure you choose a prime factor, and then you will divide, and then you write the quotient down below, and then you keep dividing if your quotient wasn't prime. So in this case, when I did 70 divided by 7, I got 10, and 10 is not prime, it's composite, so I need to keep going. So I decided to use a 5 because 5 is prime. 5 goes into 10 2 times, 2 is prime, so I know I can stop there. All right, that's the end of your review for prime factorization. Feel free to review the video again, or to visit another site such as Khan Academy, or to ask me any questions in class that you might have.